an ancient giant awakens in the cold outermost regions of our solar system. A story started billions of years prior, and presently, in a bit of enormous incongruity, little, apparently irrelevant Pluto has turned into the subject of one of the most serious galactic discussions within recent memory. Noticeable researchers, for example, Neil deGrasse Tyson and Michio Kaku, have sounded the caution about a potential crash with Neptune, which could change the destiny of our nearby planet group and influence Earth. Be that as it may, how did this worldwide dance start? What does it imply for us? And is it possible that we are about to witness one of the most terrible events in human history? The International Astronomical Union, IAU, downgraded Pluto from being the 9th planet in the solar system in 2006 to a dwarf planet. This grouping depends on its one-of-a-kind circle and little size contrasted with different planets. However, Pluto continues to captivate astronomers and the general public despite this decrease. Predictions made by well-known physicists like Michio Kaku and Neil deGrasse Tyson in recent years have raised serious concerns regarding Pluto's orbit. These expectations highlight a disastrous impact with Neptune, which could have sweeping ramifications for the whole nearby planet group, including Earth. In any case, how did Pluto end up in such a state, and how likely is it that this little, frigid world will crash into one of our nearby planet group's Goliaths? Pluto's excursion around the Sun is not normal for some other planet. It requires 248 years to finish one circle, and since its disclosure in 1930, it has not finished one full circle. Its extremely long, icy orbit, which is 17 degrees from the plane of the ecliptic, the imaginary flat surface around which the majority of planets revolve, further complicates the situation. This uncommon way permits Pluto to cross Neptune's way for a very long time in each circle. Contrary to expectations based on their positions in the solar system, Pluto moves closer to the Sun than Neptune does. This progress ups the ante in a high-stakes space game, a game with possibly perilous results. At the point when Pluto crosses Neptune's way, the power of gravity between these two heavenly bodies turns into a vital calculate deciding their future. Over the long run, these collaborations have changed, adding layers of intricacy to a complicated circumstance. The dynamics of our solar system are demonstrated by the dance between Pluto and Neptune. In spite of the fact that Pluto was viewed as a desolate exception in the external districts, its nearby experience with Neptune shows the interconnectedness of every single divine body. In order to maintain a delicate equilibrium that, if disturbed, can result in unimaginable chaos, each exerts subtle forces that influence the paths taken by the others. Astronomers can now precisely track Pluto's movements thanks to advancements in observational technology. This has prompted a superior comprehension of its circle and potential ramifications for the solidness of the external planetary group. Although a direct collision between Pluto and Neptune is unlikely, it is not entirely out of the question. The astronomical community has continued to monitor and investigate this phenomenon due to its possibility. A lot is on the line, as even a little impact can send shock waves through the whole nearby planet group. Given the intricacy of Pluto's circle, one asks why a devastating crash among it and Neptune has not yet happened. The response lies in the gravitational powers at play that keep the two divine bodies from impacting. Despite the fact that Pluto's circle differs, it is steady. Stargazers have recognized different components that assist with keeping up with steadiness, for example, a peculiarity called mean movement reverberation. Pluto and Neptune are secured. Seeing someone makes it inconceivable for a crash to happen under ordinary conditions. In any case, the issue isn't no more. Time, gravity, and the intricate dance of orbital mechanics are still working together to bring these two bodies into a potentially fatal collision. In celestial mechanics, the three-body problem is a concept that describes the intricate gravitational interactions between Pluto, Neptune, and the Sun. Tackling this issue is especially troublesome on the grounds that it includes foreseeing the movements of these articles in light of their actual collaborations, a provoking errand because of the quirky idea of these cycles. On account of Pluto and Neptune, besides the fact that their circles influence one another, yet the draw of the Sun likewise assumes a huge part. As a result, there is a delicate equilibrium that can be easily upset by even the tiniest of factors. Envision briefly that Pluto crashes into Neptune. A collision of this kind would produce a lot of energy and send shock waves throughout the solar system. Pieces from this impact could hit different planets or moons, bringing on additional harm. The gravitational safeguard that has kept our planetary group intact for billions of years could be upset, with outcomes that are challenging to anticipate. Scientists can't completely ignore the possibility, even if it seems unlikely. This potential conflict fills in as a sign of how delicate our reality is. Neil deGrasse Tyson, an incredibly famous astrophysicist, has examined the risks of Pluto's uncommon circle. According to him, the reclassification of Pluto as a dwarf planet is a significant advancement in our comprehension of the solar system. He does, however, acknowledge that the orbit of Pluto remains a mystery and has not yet been fully comprehended. Tyson's associate Michio Kaku has a fascinating point of view on this subject. Kaku, who is well known for his contributions to string theory, is of the opinion that investigating phenomena like Pluto's orbit could provide useful insights into the direction that space exploration will take in the future. He suggests that learning about the orbital dynamics and gravitational interactions of celestial bodies like Pluto could improve our ability to safely navigate the solar system and future space missions. Kaku's advantage in Pluto's circle goes past simple interest. He accepts that the gravitational powers at play in this enormous dance could give significant information to testing expectations of string hypothesis, a hypothetical system that looks to portray the principal powers and matter in the universe. Even though it would have a devastating immediate effect, a collision between Pluto and Neptune could provide a one-of-a-kind opportunity for observation, according to Kaku. The power and recurrence of the waves delivered by such an occasion could make sense of the way of behaving of particles and crucial powers under outrageous circumstances, fundamental for the investigation of string hypothesis. Tyson and Kaku concur that concentrating on Pluto's circle is significant for future space investigation. To plan safe and successful missions further into space, it is essential to comprehend the intricate interactions between celestial bodies. Illustrations gained from the circle of Pluto can be applied to other heavenly bodies and to anticipating the investigation of far-off universes. By understanding the mind-boggling mechanics of the nearby planet group, we can more readily get ready for the difficulties ahead in investigating the universe. The universe is still a mysterious place, despite our progress in our knowledge of celestial mechanics.